What are the properties of definite integrals? For the first property, the integral of a to a of f of x dx is equal to 0. This makes sense because the domain is 0. Anything times 0 is equal to 0. The second property is the integral of b to a of f of x dx, which is equal to the negative integral of a to b of f of x dx. Now let's look at an example that brings both of these concepts together. For a problem, we are given that the integral of 2 to 4 of g of x dx is equal to 7. We have to solve this, the integral of 5 to 5 of cosine of 5x dx, plus the integral of 4 to 2 gx dx. So, from our first property, we know that if the domain is 5 to 5, it's the same a to a, then it's going to be 0 because anything times 0 is equal to 0. Then we also know g of x, we can turn it around and we can just make it negative based on our second property. Doing this, we get 0 minus 7 is equal to negative 7. The third and fourth property are very similar. Basically, we're just expanding the derivative. When it's addition, we just break it up and add the integrals together. When it's subtraction, all we do different is subtract them. Our fifth property is multiplying by a constant. Basically, we can just put the constant to the outside. For the example problem, we are given three givens. Basically, we get the integral of a to b of f of x dx is equal to 2. And then we also get g of x, which is equal to 3, and the integral of h of x, which is equal to negative 1. For reference, a and b represent the domain 2 to 3. So our problem now is to get the integral of 2 to 3 of 7 times the value of f of x plus g of x dx, plus the value of the integral of 2 to 3, 9 times the value of f of x minus g of x minus h of x times d of x. Based on our fifth property, the constant property, we can just put all our constants to the outside. Then we can expand the equation. By simplifying the two derivatives down to a bunch of smaller derivatives, we can then solve the problem and substitute the values that we are given above. Through substitution, we get 7 times the value of 2 plus 3 plus 9 times the value of 2 minus 3 plus 1. From this, we get 7 times 5 plus 9 times 0, which gives us 35. Our final property is the integral of a to b of f of x dx is equal to a to c of f of x dx plus the integral of c to b of f of x dx. For the example, we are given the integral of 1 to 100 of f of x dx is equal to 11. Our task is to try to find the integral of 1 to 2 of f of x dx plus the integral of 2 to 90 of f of x dx plus the integral of 90 to 100 f of x dx. Because we have three expressions, we will need to use the sixth property twice. So in the first step, we can break the integral of 1 to 2 of f of x dx and the integral of 2 to 90 f of x dx into 1, which is the integral of 1 to 90 of f of x dx, because 2 acts as the c variable that we showed in the sixth property. Now we notice that we have an upper limit of 90 in the first integration, and then the other one has a lower limit of 90, which means we can use the sixth property again. We can combine them to get the integral of 1 to 100 of f of x dx, and then we can substitute to get us 11.